Let's look at the solution to a second order differential equation. We have this equation here, d squared dx by dt squared minus 3 dx by dt plus 2x equals 0. The initial conditions at t equals 0 are x equals 4 and dx by dt equals 3. So this can be written in a simpler nomenclature as x double dot minus 3x dot plus 2x equals 0. Now if we take the Laplace transform of these terms here, we'll have for the first term, which is the second derivative, will be s squared x bar minus sx0 minus x1. The second term here will be minus 3 times sx bar minus x0, and the third term will be 2x bar equals 0. Now what we'll do is we'll put in the initial conditions. At t equals 0, x equals 4, so that means that the x0 condition here is simply equal to the 4. So now we'll have our s squared x bar minus 4 times s. And our second condition is dx by dt, which is our x1, is equal to 3. So we simply replace that with the 3. And everything else remains the same. Minus 3 times sx bar minus 4 plus 2x bar equals 0. We'll multiply out the brackets and we'll get s squared x bar minus 4s minus 3 minus 3s x bar plus 12 plus 2x bar equals 0. Now we'll gather all the terms together in x bar, so we'll have our s squared minus our 3s plus our 2 will equal, and we'll take the 4s across the other side and we'll take the minus 3 plus 12, which becomes the plus 9. We take the plus 9 across the other side, it becomes minus 9. So finally, we'll write it in terms of x bar as it will equal 4s minus 9 all upon s squared minus 3s plus 2. Now we know that we can solve this s squared minus 3s plus 2 by putting it into the separate brackets here. So that is equivalent to s minus 1 times s minus 2. Then we can use our partial fraction expansion. We know that this is equivalent to a upon s minus 1 plus b upon s minus 2. Then we can use the cover up rule. We'll say the limit as s tends towards 1, and if we cover up the s minus 1 here, we'll be left with our 4s minus 9 all upon s minus 2, and that limit there will give us a value of 5, which is a. Similarly, we'll look at the limit as s tends towards 2 of 4s minus 9 all upon s minus 1, and that will give us a value for b equaling minus 1. So that means that we are looking for the inverse Laplace transform of 5 upon s minus 1 minus 1 upon s minus 2, and that will give us 5e to the t minus e to the 2t. So that's our final solution there. In the next video we'll look at a few more examples of this. Thank you for listening and goodbye.